What if I told you that time, the one thing you've always trusted, the one constant in your entire existence, might one day simply stop? Not pause, not slow down, but actually come to an end. It's a strange thought, isn't it? Time has always been there. From the moment you opened your eyes as a child to this very second as you listen to these words. Time has flowed forward, steady and reliable. Tick, tock. Sunrise, sunset. Yesterday, today, tomorrow. We build our entire lives around time. We measure it, track it, sometimes feel like we're racing against it. But what if time itself had a story? What if it had a beginning, a middle, and yes, even an ending? Tonight, we're going to explore something beautiful, something strange, and something utterly inevitable. We're going to journey to the end of time itself. Now, before you feel any sense of worry or anxiety, let me assure you, this isn't a story of doom or terror. This is a lullaby written in the language of the cosmos. This is a meditation on the grandest scale imaginable. We're going to travel together, slowly and thoughtfully, from this moment right now to the furthest edge of existence, where the universe itself grows quiet and still. And along the way, I promise you'll discover something wonderful about your place in this vast, ancient, beautiful cosmos. So settle in, get comfortable, let your body relax and your mind open to wonder, because we're about to embark on the longest journey imaginable, and yet, somehow, we'll return right here to this moment, to this breath, to the precious now that you're experiencing. Time is humanity's oldest companion. Think about that for a moment. Long before humans built cities, or wrote languages, or sailed across oceans, they watched the sun rise and set. They noticed the moon waxing and waning. They saw seasons change, children grow, elders age. Time was there, invisible but undeniable, carrying everything forward like a vast river that never stops, flowing. The ancient peoples didn't have clocks or calendars as we know them, but they understood time deeply. They marked it by the stars wheeling overhead, by the migrations of animals, by the flooding of rivers and the blooming of flowers. Time was sacred. It was the heartbeat of existence itself, and in a way, nothing has changed. Right now, as you lie here in the darkness, time is still doing what it's always done. It's moving forward, second by second, carrying you along with it. The clock on your wall ticks. The earth spins on its axis. The moon pulls the tides. Your heart beats steadily in your chest. All of these are expressions of time. Different rhythms playing simultaneously in the grand symphony of the cosmos. But here's where it gets interesting. Here's where the mystery deepens. What exactly is time? We talk about it constantly. We say we don't have enough of it, or that it flies when we're having fun, or that it heals all wounds. But what is it really? For most of human history, people thought time was absolute. They thought it flowed at the same rate everywhere in the universe, like a cosmic metronome keeping perfect rhythm. Then came Albert Einstein, and everything changed. Einstein showed us something extraordinary. He revealed that time isn't the rigid, unchanging thing we thought it was. Time is flexible. It bends, it stretches. It moves at different speeds, depending on where you are and how fast you're moving. Imagine that. Right now, as you listen to these words, time is passing at a slightly different rate for you than it is for someone standing on top of a mountain. The difference is tiny, impossibly small, but it's real. Someone in orbit around Earth, moving at tremendous speed, experiences time more slowly than you do. If they spent a year in space and returned, they'd be just a tiny fraction of a second younger than they would have been if they'd stayed on Earth. Time, Einstein showed us, is not separate from space. They're woven together into something called space-time, a four-dimensional fabric that can stretch and compress and curve. Massive objects like stars and planets create dips in this fabric, and those dips affect how time flows. Near a black hole, where gravity is unimaginably strong, time slows down dramatically. An hour there might equal years out here. So, if time can bend and stretch, if it can move at different speeds in different places, then perhaps it's not so strange to ask whether time itself might have a beginning and an end. And indeed, physicists tell us that time did have a beginning. About 13.8 billion years ago, in an event we call the Big Bang, the universe burst into existence, and with it came space and time itself. Before that moment, there was no before. There was no time in which the universe could exist. Time began when the universe began. And if time had a beginning, is it so impossible to imagine that it might have an ending too? Now, I know this might sound overwhelming. The idea of time ending feels strange, maybe even a little unsettling. But here's what I want you to understand. We're not talking about something that will happen tomorrow, or next year, or even in the lifetime of our son. We're talking about timescales so vast, they make human history look like a single heartbeat. We're talking about trillions upon trillions of years into the future. So there's no need for anxiety or fear. This is a thought experiment, a meditation, a way of seeing the universe with new eyes. And I promise you, by the end of our journey tonight, you'll see time and your place within it in a completely different way. You'll feel connected to something vast and ancient and beautiful. You'll understand that you are part of a story that began with the first light of the Big Bang and will continue long after your great-great-great-grandchildren's grandchildren have turned to dust and been reformed into new stars. So take a deep breath. Let it out slowly. We're going to take this journey together, one step at a time, and we won't rush. Because if there's one thing we have plenty of, it's time, at least for now. Let's begin by understanding the universe as it is today, in this moment, in this age of stars and galaxies and light. The universe right now is filled with stars. Hundreds of billions of galaxies, each containing hundreds of billions of stars, all burning bright across the cosmos. These stars are the universe's timekeepers, its clocks, its heartbeat. And to understand when and how time might end, we first need to understand the lives of stars. Stars are extraordinary things. They're born in vast clouds of gas and dust called stellar nurseries, places where gravity pulls matter together until it becomes so dense and so hot that nuclear fusion ignites. And when that happens, a star is born. Hydrogen atoms smash together in the star's core, fusing into helium and releasing tremendous amounts of energy in the process. That energy radiates outward as light and heat, and it's that light that allows us to see stars twinkling in the night sky, even though they're trillions of miles away. Our own sun is one of these stars. It's been burning for about 4.6 billion years, faithfully converting hydrogen into helium, pouring light and warmth onto Earth, making life possible. Every sunrise you've ever witnessed, every warm day you've enjoyed, every ray of light that's ever touched your skin, all of it comes from nuclear fusion happening 93 million miles away in the heart of our star. And here's something beautiful to contemplate. The light from the sun takes about 8 minutes to reach Earth, but that light, those photons began their journey long before that. In the core of the sun, where fusion happens, the energy released has to work its way outward through layer after layer of dense solar material. Photons are absorbed and re-emitted countless times, bouncing around in a random walk that takes them on a meandering path from the core to the surface. How long does this journey take? About 100,000 years. Yes, you read that right. The sunlight warming your face today began its journey from the sun's core 100,000 years ago, long before recorded human history began. So in a way, when you feel the warmth of the sun, you're touching something ancient, something that's been traveling for longer than human civilization has existed. Our sun will continue burning for about another 5 billion years. That's its life expectancy, the time it has left before it exhausts the hydrogen fuel in its core. 5 billion years is an almost incomprehensible amount of time. To put it in perspective, life on Earth has existed for about 3.8 billion years. Human beings, modern humans, have been around for maybe 300,000 years. Recorded history goes back only about 5,000 years. 5 billion years from now, if humanity still exists, it will be in a form we cannot possibly imagine. We might have spread to other star systems, evolved into beings completely different from what we are now. Or perhaps we'll be long gone, replaced by whatever comes next in the story of life. But the sun will keep burning, indifferent to whatever happens on this small blue planet. Stars, you see, don't care about us. They're not here for us. They're simply doing what stars do, following the laws of physics, converting mass into energy, shining their light into the darkness, and in doing so, they mark time. Their cosmic clocks burning through their fuel at predictable rates. Small stars burn slowly, conserving their fuel, shining dimly but steadily for trillions of years. Large stars burn hot and fast, blazing brilliantly but exhausting their fuel in just a few million years. The universe is filled with stars at different stages of their lives. Some are young, just recently formed, still surrounded by the gas and dust from which they were born. Some are middle-aged, like our sun, steadily burning through their prime. And some are old, nearing the end of their lives, beginning to change in dramatic ways. When a star like our sun begins to run out of hydrogen in its core, something remarkable happens. The core contracts, growing hotter and denser, while the outer layers expand outward. The star becomes a red giant, bloating too many times its original size. When this happens to our sun, it will grow so large that it will likely engulf Mercury and Venus, and possibly Earth as well. The sun's surface will extend far beyond Earth's current orbit, and our planet, if it hasn't been swallowed, will be scorched and lifeless, baked by the intense heat of the dying star. But again, this won't happen for 5 billion years. You can rest easy tonight. The sun will rise tomorrow and the next day, and for countless billions of days to come. After the red giant phase, a star like the sun will shed its outer layers, creating a beautiful glowing shell of gas called a planetary nebula. And at the center, the core of the star will remain compressed into an incredibly dense object called a white dwarf. A white dwarf is remarkable. It's about the size of Earth but contains about half the mass of the sun. That means a teaspoon of white dwarf material would weigh as much as an elephant. White dwarfs don't produce new energy through fusion. They simply radiate away the heat they still contain, slowly cooling over billions of years. Eventually, over unimaginable stretches of time, a white dwarf will cool completely, fading from white to red to brown to black, becoming what's called a black dwarf, a cold, dark remnant of what was once a shining star. But here's the thing. The universe isn't old enough yet for any black dwarfs to exist. Even the oldest white dwarfs in the universe are still glowing faintly. They're still warm. The universe is only 13.8 billion years old, and it takes much, much longer than that for a white dwarf to cool completely. So in a sense, we're still in the early days of the universe. We're in the age when stars shine, when the cosmos is bright and warm and full of light. Astronomers call this the stelliferous era, the age of stars. This era began about 100 million years after the Big Bang, when the first stars ignited, and it will last for about 100 trillion years until the last stars finally burn out. 100 trillion years. Let that sink in. The universe has existed for 13.8 billion years. That's 13.8 followed by 9 zeros. 100 trillion is 100 followed by 12 zeros. We're barely 1% of the way through the age of stars. The universe is young. It's in its morning, still fresh, still bright. But even morning eventually gives way to afternoon, and afternoon to evening, and evening to night. The stelliferous era will not last forever. Stars are born from clouds of gas, primarily hydrogen, the simplest and most abundant element in the universe. But there's only a finite amount of hydrogen available. As stars are born, live, and die, they lock up hydrogen in heavier elements or in stellar remnants like white dwarfs, neutron stars, and black holes. Over time, the rate of star formation slows down. Fewer and fewer new stars are born. The universe gradually darkens. Around 100 trillion years from now, the last star will form. And over the following trillions of years, those final stars will burn through their fuel and die one by one, until eventually, the universe will be filled not with shining stars, but with their dark remnants. This is the beginning of what's called the degenerate era. The age when the universe is dominated by degenerate matter, stellar remnants that no longer shine, white dwarfs slowly cooling, neutron stars, incredibly dense cores left behind by more massive stars that exploded as supernova, black holes, regions of space-time so warped by gravity that not even light can escape them, and brown dwarfs, objects that never quite became stars, that never gathered enough mass to ignite fusion in their cores. These failed stars will drift through the darkness, cold and dim, barely glowing with the faintest residual heat. By this point, the universe will be a very different place. The galaxies as we know them will no longer exist. Over trillions of years, stars and their remnants will either collide and merge or be flung out into intergalactic space through gravitational interactions. Galactic structures will dissolve. Planets, long since frozen and dead, will either fall into stellar remnants or be ejected into the void, wandering alone through the darkness. It's a somber picture, perhaps, but there's something peaceful about it too. Imagine the universe in this era. No bright stars, no glowing nebulae, no spiraling galaxies. Just darkness, punctuated by the occasional faint glow of a cooling white dwarf or the invisible presence of a black hole. It's quiet. It's still. It's the cosmic equivalent of twilight, that gentle time between day and night when the world softens and sound carries differently and everything feels hushed and reverent. And time, in this era, continues to flow. Days still pass, though there's no sun to mark them. Years still accumulate, though there are no seasons to measure them. time marches on, patient and inexorable, even as the universe grows cold and dark. But this is not yet the end. The degenerate era lasts for an extraordinarily long time, from around 100 trillion years after the Big Bang to about 10 to the 40th power years. That's 10 followed by 40 zeros, a number so large it's almost meaningless. To put it in perspective, the age of the universe now, 13.8 billion years, is a tiny, infinitesimal fraction of this timescale. During this era, black holes become increasingly important. These strange objects, born from the deaths of massive stars or lurking at the centers of galaxies, are among the most extreme phenomena in the universe. A black hole is a region where gravity is so strong that the fabric of space-time is warped beyond measure. Anything that crosses the event horizon, the point of no return around a black hole, is lost forever, pulled inexorably toward the singularity at the center. Black holes don't emit light, so they're invisible against the blackness of space. But we know they're there because of their effects on surrounding matter. When matter falls into a black hole, it heats up and emits radiation, often brilliant X-rays, before disappearing forever. But in the degenerate era, there's very little matter left to fall into black holes. The universe has been picked clean. Black holes drift through the void, occasionally merging with one another when chance brings them together. When two black holes merge, they create ripples in space-time called gravitational waves, spreading outward at the speed of light like ripples on a cosmic pond. Black holes also have a strange relationship with time. According to Einstein's theory of relativity, time flows differently near a black hole. The stronger the gravity, the slower time passes relative to an outside observer. Near the event horizon of a black hole, time slows down dramatically. If you could somehow hover just above the event horizon and look back at the universe, you'd see time speeding up. Stars would be born and die in moments. Galaxies would swirl and collide. The universe would age before your eyes. But for you, time would feel normal. This is one of the strangest predictions of relativity, and it's been confirmed by countless observations and experiments. Time is not absolute. It's relative, dependent on gravity and motion. And inside a black hole, beyond the event horizon, the roles of space and time are thought to swap. Space becomes time-like, and time becomes space-like. It's impossible to move backward in space, and inside a black hole, it becomes impossible to move backward in time. All paths lead inevitably to the singularity at the center, but black holes are not eternal. In 1974, the physicist Stephen Hawking discovered something astonishing. He showed that black holes emit radiation due to quantum effects near the event horizon. This radiation, now called Hawking radiation, causes black holes to slowly lose mass. In effect, black holes evaporate. They shrink, little by little, radiating away their energy into space. For a small black hole, the kind that might form from a single star, this process would take an unimaginably long time. A black hole with the mass of our Sun would take about 10 to the 67th power years to evaporate completely. That's 10 followed by 67 zeros. And supermassive black holes, the kind that lurk at the centers of galaxies, containing millions or billions of times the mass of the Sun, would take even longer. We're talking about 10 to the 100th power years or more. These numbers are so vast they defy comprehension. To help illustrate, consider this. If you wrote out the number 10 to the 67th power, it would have 68 digits. The number of atoms in the observable universe is estimated to be around 10 to the 80th power. So a black hole with the sun's mass would take longer to evaporate than there are atoms in the entire universe. And yet, given enough time, it will happen. Hawking radiation is patient. It doesn't care that it will take eons beyond eons. It simply continues, one photon at a time, carrying away energy, shrinking the black hole bit by infinitesimal bit. During the degenerate era, this process has barely begun. Black holes are still growing, still merging, still absorbing the occasional bit of stray matter. But as the era progresses and the universe continues to age, black holes become the last active objects in the cosmos, around 10 to the 40th power years after the Big Bang. Something else might begin to happen. Protons, the particles that make up the nuclei of atoms, might decay. Now, this is theoretical. We've never observed a proton decaying, and they're thought to be extraordinarily stable. But some theories in physics predict that protons are not absolutely stable, that given enough time, they will eventually break apart into lighter particles. If this is true, then over vast stretches of time, all the matter in the universe made of protons and neutrons, which is to say, all the ordinary matter we know, would gradually disintegrate. Planets, asteroids, the cold remnants of dead stars, everything would slowly dissolve into a thin haze of particles like electrons, positrons, photons, and neutrinos. The universe would become even emptier, even more diffuse. By 10 to the 85th power years, the degenerate era gives way to the black hole era. At this point, black holes dominate the universe completely. They're the only significant structures left. Everything else has either fallen into a black hole, been flung into the intergalactic void, or decayed into elementary particles. The universe now consists of isolated black holes separated by immense, almost incomprehensible distances. Each black hole sits alone in the darkness, slowly radiating away its mass through Hawking radiation. There are no stars, no planets, no galaxies, just black holes and the faint, cold radiation they emit. The temperature of this radiation is incredibly low for a supermassive black hole. The temperature of the Hawking radiation is a fraction of a trillionth of a degree above absolute zero. It's colder than the cosmic microwave background radiation left over from the Big Bang, colder than anything else in the universe. And yet, it's there, a faint whisper of energy leaking out of the black hole, carrying away its mass one quantum at a time. This is an era of almost unimaginable patience. If anything could experience time in this era, it would witness a universe of near-perfect stillness. Nothing changes quickly. Nothing happens suddenly. The black holes simply sit and radiate, slowly, imperceptibly, waiting for the ultimate end, and then, around 10 to the 100th power years after the Big Bang, the last black holes evaporate. They don't disappear with a bang or a flash of light. They simply fade away, releasing their final bits of energy in a quiet exhalation of radiation, and then they're gone. What's left? The universe enters what's called the dark era. By this point, the universe has reached a state called heat death, or maximum entropy. Entropy is a measure of disorder, of how spread out and evenly distributed energy is. In the early universe, right after the Big Bang, entropy was low. Energy was concentrated, matter was clumped together, and there was a lot of potential for things to happen. Stars could form, galaxies could collide, life could emerge. But the second law of thermodynamics tells us that entropy always increases. Over time, energy spreads out, becoming more and more evenly distributed. Hot things cool down, cold things stay cold. Eventually, everything reaches the same temperature, and when that happens, no energy can flow from one place to another. And without energy flow, nothing can happen. No work can be done, no stars can shine, no thoughts can be thought. This is heat death. It's not a dramatic ending, not an explosion or a collapse. It's simply the universe running down, like a clock that's wound down, like a fire that's burned out, like a song that's faded to silence. The universe in the dark era is at thermal equilibrium. The temperature everywhere is nearly absolute zero, just a tiny fraction of a degree above the coldest possible temperature. What exists in this universe? Mostly photons, particles of light, but stretched to such long wavelengths by the expansion of the universe that they're barely detectable. Electrons and positrons, perhaps, drifting alone through the void. Neutrinos, ghost-like particles that barely interact with anything, passing through the emptiness. And space itself, still expanding, still growing, carrying these sparse particles farther and farther apart. The universe is now an almost perfect vacuum, emptier than the most perfect vacuum we could ever create in a laboratory. The distance between particles is immense, measured in light years or more. And in this universe, does time still have meaning? This is where we enter deep philosophical territory. Time, as we experience it, is intimately connected to change. We perceive time passing because things happen. The sun rises, our hearts beat, thoughts flow through our minds. We remember the past and anticipate the future. But in the dark era, nothing changes. There's no distinction between one moment and the next. If you could somehow exist in this era, and you looked around, the universe would appear exactly the same from 1 trillion years to the next trillion. There's no way to mark time, no events to remember, no changes to measure. Some physicists argue that in such a state, time loses its meaning. Time becomes an abstract concept with no physical relevance. It's not that time stops, exactly, but that it becomes imperceptible, meaningless. It's like asking what time it is in a place where there are no clocks, no day or night, no reference points at all. Others argue that time continues regardless. Even if nothing observable is happening, the mathematical framework of physics still includes time as a dimension. Space-time still exists, even if it's empty. So time continues to flow, second after second, year after year, eon after eon, even though there's no one and nothing to experience it. It's an interesting question, isn't it? If a clock ticks in an empty universe, does time still pass? Perhaps the answer is that it depends on your definition of time. If time is merely the dimension in which events occur, then yes, time continues even in the dark era. But if time is the human experience of change and sequence and causality, then perhaps time has ended because there's nothing left to experience it. Either way, the universe has reached a state of profound stillness. It's not dead, exactly, because it was never alive, but it's quiet, it's at rest. It's reached the end of its long, eventful story. Imagine it for a moment. An ocean stretching out in every direction, perfectly flat, without a single ripple or wave. No wind disturbs its surface. No currents flow beneath. It simply exists, vast and still and unchanging. That's the universe in heat death. It's reached equilibrium, the state of maximum entropy, and there's nowhere left for it to go. But here's where it gets even more interesting. Is this truly the end? Or might there be other possibilities, other paths the universe could take? The heat-death scenario assumes that the universe will continue expanding forever, growing colder and emptier until nothing remains but sparse particles in a vast, dark void. And based on current observations, this does seem to be the most likely fate. The universe's expansion is accelerating, driven by something called dark energy, a mysterious force that acts like a kind of anti-gravity, pushing space itself apart. We don't fully understand dark energy. We don't know what it is or why it exists, but we can observe its effects. And those effects suggest that the universe will indeed expand forever. However, there are other theoretical possibilities, other ways the universe's story might unfold, and it's worth exploring these alternatives, not because they're necessarily more likely, but because they reveal different aspects of how time might end. One possibility is called the Big Rip. Remember dark energy, the force that's accelerating the universe's expansion. What if dark energy isn't constant? What if it grows stronger over time? If that were the case, the expansion of the universe wouldn't just continue. It would accelerate faster and faster, without limit. At first, this would just mean that distant galaxies recede from us more quickly. But eventually, the acceleration would become so extreme that it would overpower all other forces. Galaxy clusters would be torn apart, then individual galaxies, then solar systems, then planets, then molecules, then atoms themselves would be ripped apart, their electrons torn away from their nuclei, and finally, even the fabric of space-time itself would tear, ripping apart at the seams. This is the Big Rip, and if it were to happen, it would represent a true, dramatic end to time. Not a gradual fading like heat death, but a sudden, violent unraveling of reality itself. The good news, if you can call it that, is that current observations suggest the Big Rip is unlikely. Dark energy appears to be constant, at least as far as we can tell. But if it's not, if dark energy does strengthen, the Big Rip could occur as soon as 22 billion years from now. That sounds like a long time, and it is, but it's much, much sooner than heat death. It's only about 8 billion years after our sun dies. In cosmic terms, it's practically tomorrow. But again, there's no evidence that dark energy is changing, so we can probably rest easy. The universe is not going to tear itself apart anytime soon. Another alternative is the Big Crunch. This would happen if the universe's expansion were to slow down and eventually reverse. If there's enough matter and energy in the universe, gravity could eventually overcome the expansion, pulling everything back together. Galaxies would start moving toward each other instead of away. They'd collide and merge. The universe would contract, growing denser and hotter as everything falls back together. Eventually, all matter and energy in the universe would collapse back into a single point. A reverse Big Bang. Space and time would compress back into a singularity, and the universe as we know it would end. But here's the fascinating part. Some versions of this theory suggest that the Big Crunch wouldn't be the end. It would be followed by another Big Bang, creating a new universe. This is called a cyclic or oscillating universe. The universe expands, contracts, rebounds, and expands again, over and over, in an eternal cycle. In this model, time doesn't really end, it resets. Each cycle could last trillions of years, but from the perspective of the cosmos, it's just one breath in an infinite series of breaths. The universe inhales and exhales, expanding and contracting, dying and being reborn forever. It's a beautiful idea, almost poetic. The universe as a phoenix, rising again and again from its own ashes. Unfortunately, current observations don't support the Big Crunch either. The universe's expansion is accelerating, not slowing down. For the Big Crunch to happen, the expansion would need to reverse, and there's no sign of that happening. But that doesn't mean it's impossible. Our understanding of the universe is still incomplete. There could be factors we don't know about, forces or forms of matter we haven't detected. Science is always revising itself in light of new evidence. So while the Big Crunch seems unlikely based on what we know now, we can't rule it out entirely. There's one more alternative worth considering, and it's perhaps the strangest of all. It's called vacuum decay, and it relates to something called the quantum vacuum. In quantum physics, what we think of as empty space, a vacuum, isn't truly empty. It's filled with quantum fields that permeate all of space. These fields can exist in different energy states, and our universe might be in what's called a false vacuum state. Think of it like a ball balanced on a hill. The ball is stable for now, sitting in a little depression on the hillside, but it's not at the bottom of the hill. If something gives it a little push, it could roll down to a lower, more stable state. In the same way, the quantum fields of our universe might be in a metastable state, stable for now, but not in the lowest possible energy state. If the fields were to transition to a lower energy state, to the true vacuum, the consequences would be catastrophic. A bubble of true vacuum would form somewhere in the universe, perhaps triggered by a random quantum fluctuation. Inside the bubble, the laws of physics would be different. The properties of particles, the strengths of forces, everything would change. Atoms as we know them couldn't exist. Matter would disintegrate, and the bubble would expand at the speed of light, consuming everything in its path. There would be no warning. We'd never see it coming. The bubble would arrive at the speed of light, and by definition, we can't see anything approaching at the speed of light until it's already here. One moment, the universe would be normal. The next, it would be transformed, and everything we know would cease to exist. Now, before you start worrying, let me reassure you. This might never happen. The vacuum of our universe might be perfectly stable, truly at the lowest energy state. We don't know for sure, but there's no evidence that vacuum decay is imminent or even likely. It's just a theoretical possibility. One of the many ways physicists imagine the universe could end, and even if it could happen, it might not happen for trillions upon trillions of years, if at all. Or it might have already happened somewhere far beyond our observable universe. And the bubble is expanding toward us, and we'll never know until it arrives. But again, there's no reason to think this is the case. It's simply one more reminder that the universe is full of mysteries. And the end of time, if it comes, might surprise us in ways we can't currently imagine. So we have several possibilities. Heat death, where the universe expands forever and gradually runs down into cold, dark stillness. The Big Rip, where expansion accelerates without limit until reality itself tears apart. The Big Crunch, where expansion reverses and the universe collapses back into a singularity. Vacuum decay, where the quantum fields of space suddenly shift to a new state, rewriting the laws of physics. Each of these represents a different kind of ending, a different way that time might cease to have meaning. And there might be other possibilities we haven't thought of yet, other surprises waiting in the far future. But regardless of which scenario is correct, they all share something in common. They're all extraordinarily far away. Heat death won't happen until at least 10 to the 100th power years from now. The Big Rip, if it's possible at all, is billions of years away. The Big Crunch would take even longer than heat death to occur. And vacuum decay, if it's going to happen, could happen anytime or never, but there's no reason to expect it soon. The point is, time is not ending tomorrow, or next year, or in 1,000,000 years, or even in 1,000,000,000,000 years. The universe has vast stretches of time ahead of it, more time than the human mind can truly comprehend. And that brings us to an important question. Why does any of this matter? Why should we care about the end of time when it's so unimaginably far in the future? What does it mean for us, here and now, in our brief human lives? These are good questions, and they get to the heart of why we're taking this journey together tonight. Because understanding the end of time changes how we see the present. It gives us perspective. It reminds us of our place in the cosmos. You are living in a universe that's 13.8 billion years old. The atoms in your body were forged in the cores of stars that lived and died before the sun was born. You are made of stardust, quite literally. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it was created by nuclear fusion in stars, then scattered into space when those stars exploded as supernova. Those atoms drifted through space for millions or billions of years before eventually coming together on this planet, in this solar system, and ultimately in you. You are a temporary arrangement of ancient matter, a pattern that will exist for a few decades and then disperse. When you die, your atoms will return to the earth, and eventually, over unimaginable spans of time, they'll be recycled into new forms. Perhaps some of them will become part of a new organism, a tree or a bird or another human being. Perhaps some will be incorporated into rocks or water or atmosphere. And billions of years from now, when the sun becomes a red giant and engulfs the earth, your atoms will be scattered into space once more, joining the cosmic dance. Perhaps someday forming part of a new planet around a new star. Nothing is truly lost. Everything is transformed. This is the great cycle of the universe, and you're part of it. Your existence is a brief flash in cosmic time, but it's a meaningful flash. You are the universe experiencing itself. You are the cosmos. Become conscious, able to look up at the stars and wonder where you came from and where you're going. That's extraordinary. That's a kind of miracle. And the fact that the universe will one day end, that time itself might one day lose its meaning, doesn't diminish that miracle. If anything, it enhances it. Because endings give meaning to stories. If time were infinite, if the universe went on forever without change, nothing would really matter. Every moment would be like every other moment. There'd be no growth, no evolution, no stories, no meaning. But because time is finite, because things change, because there are beginnings and endings, each moment becomes precious. Your life has meaning precisely because it's temporary. The fact that you won't live forever makes the time you do have valuable beyond measure. Think about it this way. A flower blooms for a short time, and then it wilts and fades. Does that make the flower any less beautiful? No. If anything, its temporary nature makes it more beautiful, more poignant. We treasure the flower because we know it won't last. We take the time to stop and admire it, to breathe in its fragrance, to appreciate its delicate petals, precisely because we know it's fleeting. The same is true for your life. and for the universe itself. The universe is like a flower, blooming for a time in the darkness, shining with stars and galaxies and life, and one day it will fade. But that doesn't make it any less magnificent. The universe is beautiful because it's temporary, because it changes, because it has a story with a beginning, middle, and end. And you're part of that story. You're one of the countless characters in the grand narrative of the cosmos, playing your role for a brief time before exiting the stage. But while you're here, you matter. Your experiences matter. Your relationships matter. The love you give and receive, the beauty you create and witness, the knowledge you gain, the growth you undergo, all of it matters. And here's something else to consider. The end of the universe is so far in the future that it's almost abstract. It's not something you need to worry about or prepare for. It's not something that will affect your life or the lives of your children or your children's children for countless generations. The universe has time. You have time. Right now, at this very moment, the universe is alive and active. Stars are being born in distant galaxies. Planets are forming. Perhaps life is emerging on worlds we've never seen. Organisms taking their first tentative steps toward complexity and consciousness. The universe is still young, still vital, still full of potential, and you're alive right now to witness it, to be part of it. That's the gift. Not that the universe will last forever, because it won't, but right now, at this moment, you're here. You're aware. You're part of the grand unfolding. Time hasn't ended yet. It's still flowing, carrying you along, giving you moments to experience, choices to make, connections to form. So, what should you do with this knowledge? How should it change the way you live? Perhaps it should make you more present, more aware of the preciousness of now. The end of time is so distant, it might as well be infinite, but your time is limited. You have decades, if you're fortunate. Not billions of years, not trillions, just a handful of decades to experience everything life has to offer. And that's okay. In fact, it's perfect. Because knowing that your time is limited helps you appreciate it. It helps you focus on what truly matters. When you understand that the universe itself is temporary, that stars burn out and galaxies fade and even time comes to an end, suddenly your own mortality doesn't seem so frightening. You're not an exception to the rules of the universe. You're part of those rules. Everything that begins must end. Everything that's born must die. Everything that shines must eventually fade. And there's a kind of peace in accepting that. In understanding that you're not separate from the cosmos, but woven into its very fabric. When you close your eyes at night and drift towards sleep, you're surrendering to a kind of temporary ending. Sleep is like a little death, a pause in consciousness, a cessation of awareness. But you don't fear it. You welcome it. You need it. Sleep restores you, heals you, prepares you for the next day. And in the same way, perhaps the universe's ending is not something to fear, but something to accept as natural as necessary. After vast eons of activity, after countless stars have been born and died, after galaxies have danced through space and black holes have merged and evaporated, perhaps the universe deserves to rest. Perhaps heat death is not death at all, but peace. The universe, having run its course, having told its story, simply ... stops. And maybe, just maybe, that's beautiful in its own way. A story without an ending is incomplete. A song that never ends loses its structure and meaning. The universe's story will have an ending, and that makes the story meaningful. Now, I want you to think about something. Throughout this journey we've taken together, from the birth of stars to the heat death of the universe, we've been talking about time on the grandest scale imaginable. But right now, at this moment, time is also happening on the smallest, most intimate scale. Your scale, your breath moving in and out. Your heart is beating steadily. Your thoughts drift, perhaps, as you listen to these words and feel yourself relaxing deeper and deeper. This moment, right now, is the only moment you truly inhabit. The past exists only in memory. The future exists only in imagination. But now, this breath, this heartbeat, this second is real. It's happening. And in a way, it's all you have. The entire universe, with all its vast timescales and cosmic endings, has led to this moment. 13.8 billion years of history have culminated in you, here, now, experiencing this. That's profound. That's awe-inspiring. Physicists sometimes talk about the arrow of time. The fact that time seems to flow in only one direction, from past to future. We can remember yesterday, but we can't remember tomorrow. We can affect the future, but we can't change the past. This arrow is connected to entropy, to the second law of thermodynamics. Entropy always increases, disorder always grows, and that gives time its direction. In the early universe, entropy was low. There was order, structure, potential. As time passes, entropy increases. Things become more disordered, more spread out, more uniform. And we experience that increase as the flow of time. The arrow of time points from low entropy to high entropy, from order to disorder, from beginning to end. But here's the beautiful thing. You, right now, are a local decrease in entropy. Your body is highly ordered, highly complex. You take in energy from food and use it to maintain your structure, to think and move and live. You're fighting against the universe's tendency toward disorder, at least temporarily. Every living thing does this. Life is a temporary reversal of entropy, a brief, localized increase in order and complexity. And that's part of what makes life so special, so improbably. You exist in defiance of the universe's general trend toward disorder. You're a small island of order in a cosmic ocean gradually growing more chaotic. Of course, you can't fight entropy forever. Eventually, all living things die. The energy we use to maintain our bodies comes from the sun, and the sun will die too. Stars will burn out. Black holes will evaporate. Entropy will continue increasing until the universe reaches heat death, maximum disorder, perfect equilibrium. But until then, here and now, you're alive. You're conscious. You're a pattern of matter and energy that can think and feel and wonder. And that's miraculous. The universe created you, not intentionally, not with purpose, but through the blind, beautiful workings of physics and chemistry and evolution. And now you exist, for a brief time, able to contemplate the very universe that created you. You're the universe looking at itself in the mirror. You're stardust pondering its own origins. That's what consciousness is, in a way. It's the universe becoming aware of itself. And when you think about the end of time, about heat death and the dark era and the eventual cessation of all activity, remember this. You won't be there. Humanity won't be there. Even the earth won't be there. The end of time is so far in the future that nothing we know will survive to see it. But that's okay. You don't need to witness the end to appreciate the journey. You don't need to live forever to live meaningfully. Right now, in the age of stars, in this bright, warm era when the universe is full of light and life, you have the privilege of existing, of experiencing, of being. And that's enough. That's more than enough. Let's bring ourselves back now, gently, from the far future to the present moment. We've traveled to the end of time and back. We've witnessed the death of stars, the evaporation of black holes, the heat death of the universe itself. We've contemplated timescales so vast they dwarf all of human history. And now we're here, right now, together. Tomorrow, the sun will rise. You'll wake up, and time will continue. Stars will keep burning. The earth will keep spinning. The universe will keep expanding. And you'll have another day, another collection of moments to experience life in all its complexity and beauty. The end of time is not something you need to fear or worry about. It's not coming tomorrow or next year or in any time frame that has any relevance to your life. It's a distant horizon, a theoretical endpoint in the far, far future. And between now and then, there are countless moments, each one unique, each one precious. Your life will unfold moment by moment, day by day, year by year. You'll experience joy and sorrow, success and failure, connection and solitude. You'll watch sunsets and taste food and hear music and feel the warmth of loved ones. You'll think and dream and imagine and create. You'll be alive, fully and completely, for as long as you have. And when your time comes to an end, as it must, your atoms will return to the universe, joining the great cycle of matter and energy that's been unfolding since the Big Bang. Some of your atoms might become part of the earth, resting in soil or stone for millions of years. Some might be taken up by plants or animals, becoming part of the web of life. And billions of years from now, when the sun expands into a red giant, your atoms will be released back into space, scattered among the stars, free to begin new journeys we can't imagine. In this way, you're part of something eternal, even though your individual existence is temporary. The matter that makes you has existed for billions of years and will exist for billions more. You're just a temporary pattern, a brief arrangement. But you're part of an ongoing story that's much larger than yourself. And there's comfort in that. You're not separate from the universe. You're not a stranger in a cold, indifferent cosmos. You are the cosmos. You're a piece of it that's alive and aware, experiencing existence from a unique perspective for a little, while before dissolving back into the whole. So as you lie here tonight, feeling yourself drifting toward sleep, carry this with you. The universe is vast and ancient and strange, full of wonders beyond imagining. It had a beginning, and it will have an ending. Time itself will one day lose its meaning as the cosmos fades into cold, dark stillness. But that ending is so far away it's almost mythical. Right now, the universe is alive. It's dynamic. It's full of light and energy and possibility. And you're part of it. You're here, now, in this moment, breathing, feeling, existing. That's a miracle. Not that you'll live forever, but that you're alive right now. So rest easy. The universe holds you. Time holds you. You're safe. You're connected. You're part of something vast and beautiful. The end of time will come, eventually, but not tonight. Tonight, there's just this breath, this moment, this gentle drift toward dreams. The cosmos continues its slow dance through the ages, and you, for now, are one of the dancers. Close your eyes if you haven't already. Feel the weight of your body sinking into the bed. Feel gravity, that fundamental force of the universe, gently pulling you down, connecting you to the earth beneath you. Feel your breath, slow and steady, air moving in and out of your lungs, the same air that's been part of Earth's atmosphere for billions of years, breathed by countless organisms before you. You're breathing ancient air, just as you're made of ancient atoms. Everything is connected. Everything is part of the same cosmic story. And in this moment, you're exactly where you need to be. Time is flowing forward, carrying you along, and there's nowhere else you need to go, nothing else you need to do. You can simply rest, simply be. The universe will continue without you needing to manage it. Stars will keep burning. Planets will keep orbiting. The great cosmic clock will keep ticking, second by second, eon by eon, all the way to that distant ending we've imagined together. But that's the universe's concern, not yours. Your concern is simpler, more immediate, more personal. Your concern is this breath, this moment, this gentle slide into sleep. Let yourself drift now. Let your thoughts become softer, hazier, less defined. Let the images and ideas from our journey float away like clouds dispersing in the sky. You don't need to hold on to them. They've done their work. They've given you perspective, a sense of connection, a feeling of wonder, and now they can fade, leaving behind only a gentle sense of peace. The universe is vast, but you are here, in this small, warm, safe space. Time stretches out in both directions, into the distant past and the unimaginable future. But you exist in the eternal now, and that's the only place you ever need to be. So sleep now, rest, dream whatever dreams may come, and know that when you wake tomorrow, time will still be here, still flowing, still carrying you forward through your own unique story. The end of time is not your end. Your end will come much sooner in the natural course of a human life, and that's perfectly okay. When it comes, you'll have lived. You'll have experienced it. You'll have been part of the universe's grand unfolding, and that's all anyone can ask for. But tonight, there is no ending. There is only rest, only peace, only the gentle rhythm of your breathing and the slow, steady beat of your heart. You are alive. You are aware. You are part of something infinite and eternal, even though your own time is finite. And in this paradox, in this tension between the temporary and the eternal, there is beauty. There is meaning. There is grace. The universe created you, and for a little while, you get to exist, to experience, to wonder, and then you'll return to the universe, becoming once again the stardust from which you came. It's a beautiful cycle, a perfect circle, a story with a beginning, middle, and end. Your story, the universe's story, one and the same. So rest now, traveler. You've journeyed far tonight, to the very edge of time itself, and now you've returned home, to this moment, to this breath, to this perfect now. Sleep well. The cosmos will be here when you wake, ancient and patient and beautiful, still unfolding its timeless dance among the stars. And you'll be here too, alive for another day, ready to add another small chapter to the grand story of existence. Until tomorrow, then. Until the next breath, the next heartbeat, the next sunrise. Rest in the knowledge that you are exactly where you belong, held gently by the universe, cradled in time, part of everything that is, was, and will be. Sleep now. Let time carry you into dreams. All is well. All will be well. The end of time is far, far away, and tonight there is only peace.